Topic for the day, indices. We can expect 2 questions in your 9th final exam from this topic, most likely. Okay. You have studied this topic in class 8th. We will now go deeper into this topic and see some better problems. Before that, let us have a quick revision of various laws of indices. Anyway, before coming to the laws, you are expected to learn certain powers. Like now see, 2 raised to 1, 2 raised to 2, dot 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 up to 2 raised to 10. This values you need to learn. So 2 raised to 10 will be 1024, and in between values you can work it out and learn. Then 3 raised to 1, 3 raised to 2, dot 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 up to 3 raised to 5. This is good enough. Then 4 raised to 1, 4 raised to 2, up to 4 raised to say 5. Then 5 raised to 1, 5 raised to 2, up to 5 raised to 4. 6 raised to 1, 6 raised to 2, up to 6 cube is sufficient. Then 7 raised to 1, 7 raised to 2, up to 7 cube, 7 cube, fine. Then 8 raised to 1, 8 raised to 2, 8 raised to 3. Then 9 raised to 1, 9 raised to 2, 9 raised to 3. Then you have 11 raised to 1, 11 square, and 11 cube you need to learn. 11 cube is 1331. Then 12 raised to 1, 12 raised to 2, 12 raised to 3. 12 raised to 3 is 1728, not 1278, because 11 cube is 1331. So 12 cube will be more than that, that is 1728, because people do confuse between 1728 and 1278. So remember, 12 cube is 1728, more than 11 cube. So these values you will have to learn. So whenever you look at those numbers, you should be able to recognize, oh, this is 4 cube, this is 7 cube, this is 2 raised to 5, like that. Okay, consider 5 raised to 2. 5 is known as the base and 2 is known as the index or the power. Normally base is written little bigger than the index. Okay, or I would say index is written, the size of this font size should be a little smaller, just so that one can distinguish between base and power. So 5 square is how much? 25. Okay. Now let's come quickly to laws of indices. So you have first one, a raised to m into a raised to n is a raised to m plus n. So here we take a as our real number and m and n are rational numbers. So a belongs to R and m and n belong to set of rationals. We restrict ourselves to these things. Okay, so the base will be a real number and your index will be a rational number, q. So a raised to m into a raised to n is a raised to m plus n. So this law is better understood how, if the bases are same, if the bases are same joined by multiplication sign, then the powers can be added. If the bases are same joined by multiplication sign, then the powers can be added. Example, 5 raised to 2 into 5 raised to 3. 5 raised to 2 into 5 raised to 3. So bases are same here, joined by multiplication sign, so the powers can be added. So this will be 5 raised to 2 plus 3, that is 5 raised to 5. Of course, this value is too big to compute, but one can compute it. It is 5 into 5 into 5 into 5, like 5 times. Second, a raised to m divided by a raised to n. A raised to m divided by a raised to n. This will be a raised to m minus n. So m minus n goes in the power. So what the law says here, if the bases are same, joined and the two terms are joined by division sign or the upon sign, then the powers would be subtracted. Example, 6 raised to 4 upon 6 raised to 2. 6 raised to 4 divided by 6 raised to 2. This will be 6 raised to 4 minus 2. The powers will be subtracted, that is 6 raised to 2. Now here you have to be careful. Suppose if it is 6 raised to 4 upon 6 raised to minus 2, then what this will be? See, the second law will apply. The bases are same and the two terms are joined by a division sign. So in such case, what do? We subtract the powers. So this will be now 6 raised to 4 minus 2. This you take care. 6 raised to 4 minus 2, because 1 minus comes because of the law and this is n. But here n itself is negative. So it comes minus 2. This minus 2 comes up and this minus sign comes because of the law. So eventually this will become 6 raised to 6. This was the second law. There are names for it, but you need not remember the names. You should be able to judge which law to apply. So we have done this, we have done the second one. Let's move on. So what we are doing is, here we are taking the base as the real number and your index as the rational number. Third one, a raised to m raised to n. A raised to m, the whole raised to n. This will be a raised to mn. The two powers will get multiplied. A raised to m, the whole raised to n, that is a raised to mn. Example, 2 raised to 3, the whole raised to 5. 2 raised to 3, the whole raised to 5. This will be 2 raised to 15. 2 raised to 3, the whole raised to 5. The two powers will get multiplied. This will be clearly 2 raised to 15. Then next, a into b, the whole raised to m. A into b, the whole raised to m. This, so m will be given to the first term, m will be given to the second term. This will be a raised to m into b raised to m. Take care, this is not a plus b the whole raised to m. It is multiplication sign. Then only the power can be given like this. Example, 2 into 5, the whole raised to 3. We can do this 2 into 5, 10 and 10 cube. That is also okay. But if I want to give the powers, then it will be 2 raised to 3 into 5 raised to 3. So we have done up to this fourth one. Then a upon b, the whole raised to m. A upon b, the whole raised to m. This will be a raised to m upon b raised to m. The same power will be given to both the terms if it is multiplication sign or division sign. So a upon b, the whole raised to m will be a raised to m upon b raised to m. Example, 3 upon 5, the whole raised to 4. This will be 3 raised to 4 upon 5 raised to 4. Then a raised to minus m, negative index, a raised to minus m. How to deal with it? Here what you do, whatever base you are having, you just take the reciprocal of it. Okay, when you reciprocal the base, what is reciprocal? Interchange of numerator and denominator. So when you reciprocal the base, the power will change the sign. So a raised to minus m will be same as 1 upon a the whole raised to m. See, this a means what? It is a upon 1. So if I reciprocal, it will become 1 upon a, and the power is minus, so it will become plus. So a raised to minus m is 1 upon a the whole raised to m. Example, 2 upon 7 the whole raised to minus 3. 2 upon 7 the whole raised to minus 3. Now see, how do we define a negative index now? It's very odd, I mean, 2 upon 7 raised to 3, we can visualize. It is 2 upon 7 into 2 upon 7 into 2 upon 7. But this is 2 upon 7 the whole raised to minus 3. So here this law comes to our rescue. This will be 7 upon 2 the whole raised to 3. So basically what we are doing, we are simply taking the reciprocal of the base. If we take the reciprocal of the base, the power changes the sign. So minus 3 will become plus 3. Suppose if this was 3, it was 2 upon 7 raised to 3, then it will become equivalent to 7 upon 2 raised to minus 3. Okay. Few more before we come to problems. A raised to 0 is 1. Okay, a raised to 0 is 1. Example, 7 raised to 0 is 1, minus 3 raised to 0 is 1, 0.8 raised to 0 is 1, and so on, but not 0 raised to 0. Okay, this law, anything raised to 0 is 1. So we have seen these examples. Now what is remaining? Yeah, we have covered everything. Yeah, but one more thing. Now see, 1 raised to anything is 1. 1 raised to anything is 1. So 80 means anything. So 1 raised to 0.3 will be 1. 1 raised to 100 will be 1. 1 raised to minus 100 also will be 1. Let us see how it comes. 1 raised to minus 100. Power is negative. So which law will come in the picture? Just now we did, I think law number 6. Yeah, possibly a raised to minus m is 1 upon a the whole raised to m. So we will reciprocal the base. So when I reciprocal of 1 is 1 only. This will become 1 raised to 100. So 1 raised to 100 means 1 into 1 into 1 into 1. This way you do 100 times. So that will be 1. Okay. Now let's see what if it is negative 1. Then what happens? Now see, minus 1 raised to 40 will be minus 1. No, this will be plus positive 1 because this is even power. So minus 1 raised to 40 means you will do minus 1 into minus 1 into minus 1. So 40 times. So signs will balance out each other. Na? Minus into minus is plus. So for even hai, so the signs will balance out each other. But if it is minus 1 raised to 39, then this would be minus 1 because it is odd power. So minus 1 raised to even power is 1 and minus 1 raised to odd power is minus 1. Okay. So this completes with your concepts and fundamentals. Certain powers you had to learn, which I told you, and power of 10 also, that is understood. 10 square is 100, 10 cube is 1000. That no need to learn. I mean, you can just quickly calculate. We have told you the laws of indices. Yeah, that's it. Now we can come to problems. Question 1. Evaluate 16 upon 18 the whole raised to minus 3 by 4 into 49 upon 9 the whole raised to 3 by 2 divided by 343 upon 216 the whole raised to 2 by 3. Okay, so multiplication, division, sum powers, evaluate, simplify. So in the exam you will directly copy this expression and then start. Here I am just directly starting to save space. Now see, 16 upon 81, whatever powers we had given you in the beginning, you have to learn those. So you will be able to recognize quickly that this is 4 upon 9 the whole square, because 4 square is 16, 9 square is 81. So nothing wrong if I write this as 4 upon 9 the whole square. But here it is minus 3 by 4. So it is better if we write this as 2 upon 3 the whole raised to 4, isn't it? So 2 raised to 4 is 16, 3 raised to 4 is 81. So we have not changed the value, we have just changed the form. The entire thing raised to minus 3 by 4. This is okay. Now you may have a doubt that since the power is negative, why not reciprocal the base? A raised to minus m is equaling 1 upon a the whole raised to m. That is also fine. You can write this as 81 upon 16, 81 upon 16 the whole raised to 3 by 4. When the base is reciprocal, the power changes the sign. The power does not get reciprocal. When the base is reciprocal, the power changes the sign. So this can be written as 81 upon 16 the whole raised to 3 by 4, and then you can proceed. That is also okay. Coming to the next term, this can be safely written as 7 by 3 the whole square, the full thing raised to 3 by 2. 7 square is 49, 3 square is 9. Okay. See, the 343 is easily recognizable, and 216 also. This is 7 by 6 the whole cube raised to 2 by 3. Okay, now a raised to m the whole raised to n. Remember that law, a raised to m, this is like a raised to m, the entire thing raised to n. So what it is? A raised to mn. The two powers have to be multiplied. So if I do 4 into minus 3 by 4, the two powers will get multiplied. So this will get cancelled. You will be left with minus 3. So here the two powers have to be multiplied and the base has to be kept as it is. So this will be 2 by 3, 4 into minus 3 by 4. So that is raised to minus 3 into, here again 2 and 2 gets cancelled because a raised to m, the whole raised to n, that is a raised to mn. So the two powers will get multiplied. This is 7 upon 3. So 2 into 3 by 2. 2 into 3 by 2. So the 2 and 2 will get cancelled. You will be left with this. Same thing applies here. What you will be left with? 3 into 2 by 3. 3 into 2 by 3. So that will turn out to be raised to 2. Now we can reciprocal the base here. Because everything is now done, we have to open up the brackets and just simplify. So we will reciprocal the base here so that minus 3 becomes 3. Negative power becomes positive. So when we reciprocal the base, power changes the sign. Into 7 upon 3 raised to 3 divided by 7 upon 6 raised to 2. Till here it is fine. Okay, now this we will erase. Here now we have reached a stage where nothing is there much now. All negative powers have been taken care of, numbers are also small, so we open up the brackets. So this we will write it as 3 by 2 into 3 by 2 into 3 by 2, because a cube is what? A into A into A. So same thing, into 7 by 3 into 7 by 3 into 7 by 3 divided by, so this we take it as 7 square is 49 and 6 square is 36. Okay with this? Now hold on, this will be again 3 by 2 into 3 by 2 into 3 by 2 into 7 by 3 into 7 by 3 into 7 by 3 multiplied by 36 upon 49. See, here I have not reciprocaled the base or something, nothing of that sort. I mean, we have not used the law a raised to minus m is 1 upon a raised to m. It is not like that. Because this is division, this becomes multiplication and we reciprocal. Example, if you had 1 upon 7 divided by 11 by 12, how you would have evaluated this? This would be 1 by 7 into 12 by 11. Correct? So that is what we have done. We have not applied any law of indices or something here. So now this has come all in the nice. So this division will become multiplication and 49 by 36 will become 36 by 49. We just need to see what is getting cancelled now. Okay, 3 here. This 3 will get cancelled with this 3. This 3 will get cancelled with this 3. This 3 with this 3. Okay. Now see, 7 into 7, 49 will get cancelled with this 49. 2 into 2, 4. 2 into 2, 4 will get cancelled with this 36 9 times. And now we are left with what? Have we missed out on anything? No, no. So this will come to 9 upon 2. Okay, see, 3, 3, 3 gets cancelled. 7 by 3. Okay, this is also fine. 7 by 6, this will become, is there any problem here? I feel something, yeah, no. This was 7 by 6, the whole raised to 3. That became 49 upon 36, that is into 36 upon this. Okay, here, this one 7 is left. So 9 into 7, 63. 63 divided by 2. Yeah, rest all are getting cancelled. Now, since it is divided by 2, it is coming exact decimal. So you can write this as 31.5. But if it was not exact decimal, then you can just put it in mixed fraction format and you can leave it. But then your fraction should be in the simplest form. That is most important. Here we can write it as 31.5. This question can come as evaluate or simplify. Fine. This completes with your question 1. Question 2. If 1960 is 2 raised to a into 5 raised to b into 7 raised to c, find the value of this 2 raised to minus a dot, that is into 7 raised to b into 5 raised to minus c. It's a typical sum, prime factorization. So what we do is, in fair, we can show like this: 1960, the starting is what? 2. So take all the starting with 2, exhaust it, then don't think what will happen. Take 5, exhaust it, then take 7. The clue is already given here. So 1960 has been written as product of primes. You need to find out what would be their powers. So start with 2 because it is starting here with 2. 2 9s are 18, 1, 2 8s are 16, 2 4s are 8, then 2 2s are 2 4s are 8, 245, yeah. Now it won't go with 2, right? So you take 5 because the next factor is 5. So 5 4s are 20, 4 balance 9. Again 5 will not no go, it is exhausted now. So now take 7. 7 7s are 7 1s are. So 1960 can, this you show it in fair. 1960 can be written as 1 2 3. This can be written as 2 raised to 3 into 5 raised to 1 because it comes only once into 7 raised to 2, isn't it? 2 cube into 5 raised to 1 into 7 square will give you back 1960. But they are saying that 1960 is this. So instead of 1960, we will write 2 raised to a into 5 raised to b into 7 raised to c. Because 1960 is this according to us, but they have said 1960 is like this. So 1960 will be replaced with what is given, equal to what we have obtained. Now, see, bases are same. This you have studied in class 8th also. Simple equations. If bases are same and the expressions are same, then the powers will also be equal. So 2 with 2, so a will be what? 3. Then 5 raised to b is equaling 5 raised to 1. Bases are same, so powers can be equated. So b will be 1. Then 7 with 7, so c will be what? 2. So a is 3, b is 1, 7 is 2. We have decoded this, but they want the value of something else. Now 2 raised to minus a into 7 raised to b into 5 raised to minus c will be, this will be equal to 2 raised to minus a. A is what? 3. So 2 raised to minus 3 into 7 raised to b. What is b? 1. Into 5 raised to minus c. What is c? 2, but minus c. Now this you just need to evaluate. 2 raised to minus 3, negative power. So what do? We reciprocal the base. When we reciprocal the base, index or the power changes the sign. So this will be 1 upon 2 raised to 3 into 7 into 1 upon 5 raised to 2. 1 upon 8 into 7 into 1 upon 25. This will be 7 upon 200, right? 25 into 80, yes. We can leave it like this. A very standard 3 marks or 4 marks question. If this comes, it's good. I mean, nothing much to think. There is a fixed procedure for it. So this completes with your question 2. Question 3. Simplify 5 raised to n plus 3. So n plus 3 is the power, minus 6 into 5 raised to n plus 1, the whole divided by 9 into 5 raised to n minus 5 raised to n into 2 square. See, be careful, this is one term now, and 6 into 5 raised to n plus 1 is another term, and the two terms are joined by minus. And in the denominator, you have 9 into 5 raised to n minus 5 raised to n into 2 square. So this is one term. This is one term, this is your other term joined by minus. You can't cancel 5 raised to n and 5 raised to n. Think like this. Let 5 raised to n be x. Let 5 raised to n, that entity gatha, be x. So it will be what? 9x. And this will become what? X into 2 square minus 4x. Can you cancel this x and x like this? No. So same way, because 5 raised to n is getting pulled with 9 multiplication. And this 5 raised to n is getting pulled towards 2 square. So this is one term, this is another term joined by minus. So 9x is like 9x minus 4x. X and x cannot be cancelled. So how do we go about it? Wait, now see, this is 5 raised to n, something simple power. So we will have to do here reverse splitting. Keep this technique in mind, it could be useful in some other sums also. Now recall the law, the very first law. a raised to m into a raised to n. This is a raised to m plus n. So if we go reverse, a raised to m plus n will be a raised to m into a raised to n. Reverse is also true. So that is what we will do. So here what we will do, we will write this as phi raised to n into phi raised to 3. Phi raised to n into phi raised to 3. If you want to check if we are correct or not, just apply the law. Bases are same. Bases are same joined by multiplication sign. So powers will have to be added. So this will become phi raised to, this whole thing will become phi raised to n plus 3. And that is phi raised to n plus 3. Okay, so reverse we are going now. Now this will be 6 is okay. अभी ऐसे ही रखते हैं. Phi raised to n plus 1 को we will split. We will write this as phi raised to n into phi raised to 1. Again, let's see if we are correct. Phi raised to n into phi raised to 1 will be phi raised to n plus 1. Bases are same, so powers can be added if there is multiplication sign. So this entity gives us back this, so we are correct. And other things I have copied down as it is. Here nothing much can be done. This is one term, this is another term. Already we have like a simple power phi raised to n. तो what इसको क्या split करेंगे अभी? Here also phi raised to n. If it was phi raised to n plus 2 or phi raised to n plus 7, then we could have split. But it is in a simplest form. So we will copy down as it is. 9 into phi raised to n. Yes, 9 you can write it as 3 square, no harm. But then it won't help you here in much. If you see, you can write it 3 square. Again you want, you can convert it into 9. So minus phi raised to n into 2 square. Observe, here factorization comes to your rescue, elementary factorization. This is one term. In maths we know x plus y is a binomial, two terms, and xy will be taken as a single term. So this is one term and this is your second term. What can we take common from this? We can take phi raised to n common, isn't it? Here phi raised to n, here also phi raised to n. Of course, even this can be taken common, but we will see that later on. But phi raised to n at least can be taken common. So here you are left with phi raised to 3, because this is taken out, minus 6 into this phi raised to n is already taken out. So we are left with 6 into phi raised to 1. Something similar we do it in the denominator. This is one term and this is your second term. Here phi raised to n we take common. This will be 9, okay, minus, this is already here, 2 square will come, that is 4. Now see what happens, phi raised to n, phi raised to n, that entire term gets cancelled because this is multiplication sign, this is also multiplication sign. So two identical terms joined by division will easily get cancelled. And now we are left with this small thing which we just need to simplify. Phi cube 125, phi raised to 1 is 5 into 6, that is minus 30. The whole divided by 9 minus 4 is what? 5. 125 minus 30, how much? 95. So 95 upon 5. This nicely works out to be 19. So these sums are pretty important. They are easy, but you need to know that one term here joined by minus, down also minus, or it could be plus also, nothing like that. So here the trick is to remove something common and use reverse splitting. Fine. So keep this sum in mind, and rather the technique and the experience which you have obtained by solving this sum, that needs to be kept in mind, because this could be fused with something else and a new sum can be framed. So this completes with your question 3. Question 4. Prove that x raised to a into b minus c. So a into b minus c is the power and x is your base. Divided by x raised to b into a minus c. The whole expression, this divided by x raised to b upon x raised to a, the whole raised to c is equaling 1. Simple proof, they just appear complicated. You just play with the laws. Prove that this is equal to 1. Now, since this is proof that sum, we can't assume it to be equal to 1 naturally, right? So, we will take LHS. So, this will be x raised to a into b minus c, the whole divided by x raised to b, this divided by x raised to b upon x raised to a, the whole raised to c. Now, there is no fixed way, you have to observe, see which law will be better, which will yield to the result faster. I mean, it depends the way you think. It is not that, okay, this is a good method or this is a bad method. It is just a fusion of medley of laws and how you just play with it. Okay. Now, I feel like opening this bracket AB minus AC, because see, here there is one base, here there is one base. Same base divided by, joined by upon sign, division. So, which law can come? A raised to m divided by a raised to n. Yes, bases are same, so powers can be subtracted. So, I feel that should be used here. Now, we will open up the brackets little. This we will write it as x raised to AB minus ACC, right at the same level. Otherwise, if you write minus AC here, it will become another term. You will get confused. It is AB minus AC is like a power and x is the base. So, I have written little base little bigger so that you can distinguish between the power and the base. So, here which is the base? X. Which is the index or what is the power? AB? No, it is AB minus AC. X raised to BA minus BC. Okay, now here again the bases are same, so the powers can be subtracted. This is one approach. Other approach will be, you remember this law, A upon B raised to M will be A raised to M upon B raised to M. So, you have to observe a lot in indices, stare at it for a few seconds, see what strikes your mind. So, power can be given to the numerator, power can be given to the denominator, that is also okay. So, we can write this as x raised to B, the whole raised to C, upon x raised to a, the whole raised to c. The power will be given to both. So, then the two powers will get multiplied now. A raised to m, the whole raised to n, that is a raised to mn. That is also fine. Okay, that you should apply, but fine. Here we realize that the bases are same. The bases are same. So, these two powers can be subtracted. So, I would write this as x raised to b minus a, the whole raised to c. Okay, a raised to m upon a raised to n, that is a raised to m minus n, the whole raised to c. This we will now erase. Remember, we are on LHS. Now what to do? Bases are same, so now the powers can be subtracted. So this would be x raised to AB minus AC minus BA plus BC. The bases are same and then the powers to be subtracted. So, AB minus AC, this is the original, this is like M minus N. So, it is minus BA plus BC, because the law is what? A raised to M upon A raised to N is A raised to M minus N. The two powers will get subtracted. So, it is AB minus AC minus this thing. So, that is minus BA plus BC divided by This is like a raised to m, the whole raised to n. A raised to m, the whole raised to n. That is a raised to mn. The two powers will get multiplied. So this will be x raised to ab minus, no, cb, sorry. This will be x, so the two powers will get multiplied. This will be x raised to bc minus ac. Are you convinced with this? A raised to m, the whole raised to n is a raised to mn. The two powers get multiplied. So b minus a into c, that is bc minus ac, and this comes as a power. Fine, this I'll erase. Now here again your luckily bases are the same and there is a division sign or upon sign, one and the same thing. So what to do with the powers? Powers can be subtracted. But before that, let's see if this can be, this results in something smaller. Yeah, nice. AB minus BA, oh gone. So this works out to be x raised to minus AC minus, no, plus BC, minus AC plus BC divided by x raised to BC minus AC. Now there is a division sign here, bases are same, so the powers can be subtracted. So this will be x raised to minus AC plus BC minus BC plus AC. We are subtracting this. We are subtracting, what are we subtracting? This we are subtracting. So when you open the bracket, signs will change. Now minus AC plus AC gone, BC minus BC gone, so that comes to what? 0. So x raised to 0. What is x raised to 0? 1. And this is exactly equal to our RHS. Right? If you see the original question, RHS is 1. So we have simplified this, x raised to 0 we get it, and x raised to 0 is 1, which is equaling RHS. Hence proved. A middle level sum. Okay. This completes with your question number 4. Question 5. Solve for x. 4 raised to x minus 2 minus 2 raised to x plus 1 is equaling 0. These are like exponential equations, like equations involving your indices, involving exponents. They are manageable, I mean they are not really very difficult. Here the idea is to make the bases the same so that we can equate the powers. Okay. Question says 4 raised to x minus 2 minus 2 raised to x plus 1 equaling 0. Now see, if you feel that we can write 4 as 2 square, perfectly fine. Nothing wrong in that. But there is a minus sign here. You will not be able to subtract the powers. When can we subtract the powers? When there are two terms joined by division. Plus the bases should be the same. So what some of you may be thinking, 4 can be written as 2 square and then the power will become 2x minus 4. Good enough. And here also 2, here also 2. Then again you will subtract the powers. No. Powers can be subtracted, one, if the bases are the same. You have made the base the same. Great. But there should be division sign. What is the law? A raised to m divided by a raised to n is equaling a raised to m minus n. But here there is no division sign, there is minus sign. So what we can do, this whole term, we can shift it that side. So this will become, now see this is given 4 raised to x minus 2 minus 2 raised to x plus 1 is 0. This term we can shift it there. So 4 raised to x minus 2 is equaling 2 raised to x plus 1. Now 4 can be written as 2 square. Idea, because here the base is 2. Na? So 4 can be written as 2 square. The whole raised to x minus 2 is equaling 2 raised to x plus 1. Now this is like a raised to m the whole raised to n. That will be a raised to mn. So let's come on this side. This will be 2 raised to 2x minus 4. 2 will get multiplied by x minus 2. 2 raised to 2x minus 4 is equaling 2 raised to x plus 1. Okay, this is nice. Now the two things are equal, bases are same, so we can equate the powers. So 2x minus 4 is equaling x plus 1. We can equate the same, bases are same, so powers can be equated. Now transpose this, so x will be 1 plus 4, so x will be 5. Isn't this quite simple? So the value of x which satisfies this equation is 5. And this completes with your question number 5. Question 6. Find the values of m and n if 4 raised to 2m is equaling cube root of 16, the whole raised to minus 6 upon n equaling square root of 8 the whole square. This equaling this equaling this. Okay. And we need to find the values of m and n. See, now this is unknown, this is also unknown. This is like fully known. So what we can, and all three of them are equal. So we can equate the first with this, with the last. We can equate the second where this is unknown with the last. So here it will be 4 raised to 2m is equaling cube root of 16 raised to minus 6 upon n, and not like, sorry, this will be 4 raised to 2m. Yes, both of them are equal, but then isko equate karke fayda nahi hai because this is m is unknown, n is also unknown. All three are equal. This is a pure number. So this we will equate to this. So it will be root 8 square, and then we will equate this expression with this. So it will be cube root of 16 raised to minus 6 upon n is equaling root 8 square. Good enough. Now see, try to express as power of 2. Let's see. So this 4 can be written as 2 square raised to 2m. So square root of 8 is what? 8 raised to half. This you are aware of, na? Nth root of x. Remember, nth root of x will be x raised to 1 by n. Example, 7th root of x will be x raised to 1 by 7, and so on. This you are aware of. Okay. Again, this is of the type a raised to m, the whole raised to n. That is a raised to mn. So it will become 2 raised to 4m. Now 8 can be written as a power of 2, the base. So 2 cube. So as a result, the bases will get equalized. 2 cube is also 8. So no harm. We are not changing any value. The whole raised to half. And this will become 2 raised to 4m. Power raised to power. 2 powers will get multiplied. 2 raised to 3 by 2. Now the terms are equal. Bases are same. So we can equate the powers. 4m is 3 by 2. 4m is 3 by 2. Cross multiply. How to find m now? Okay, this I'll erase. This will become 8m is 3. So m will be 3 by 8. So this completes your m. Unknown m is now known. Now we will look here. This is cube root of 16. So this can be written as 16 raised to 1 by 3, isn't it? Nth root of x is x raised to 1 by n. So this will be 16 raised to 1 by 3, the whole raised to minus 6 upon n. ये तो पहले से ही था. This can be written as 8 raised to half, square root of 8, there is a hidden 2 out here, that is 8 raised to half, the whole raised to 2, do not forget to put this 2, this is original. So this is 8 raised to half, the whole raised to 2. Okay, now what to do? We can't equate like this, no? 16 and 8. 16 can be written in another format. So anyway, let's first multiply these two powers. 16 raised to 1 by 3, the whole raised to minus 6 by n. Power a raised to m, the whole raised to n. That law can be applied. So is a raised to mn. So this will be 16 raised to, here we will have to multiply the two powers. 1 by 3 into minus 6 by n. The two powers have to be multiplied. So I have multiplied. There is scope to simplify. It comes minus 2 by n. So this will be 16 raised to minus 2 by n, equaling again a raised to m, the whole raised to n, that is a raised to mn. So half into 2, that is 1. So this will become 8. Okay, now we have simplified to a nice extent. Okay, now how do we get the bases the same? 16 can be written as 2 raised to 4. 2 raised to 4, the whole raised to minus 2 by n. This will be 2 raised to 3. Again a raised to m, the whole raised to n. So two powers will get multiplied. This will give you minus 8 upon n. So 2 raised to 3, bases are same. The powers can be equated. So it will be minus 8 is 3n, implies minus 8 by 3 is equaling n, or better n is minus 8 by 3. We can leave it like this, or you can put this in the mixed fraction form. 3, how much? 2, 3 2 is 6, 2 by 3, right? Yeah, 2 minus, if you want to put in the mixed fraction form, it will be minus 2 by 3. See, 3 into 2, 6. 6 plus 2, 8. And this minus sign is meant for the entire thing, okay? So if you want to put this in the mixed fraction form, then it will be n is equaling minus 2 by 3. So we have successfully found the values of m and n under the given conditions. This completes with your question 6. Question 7. Solve for y. 2 raised to 3y plus 3. So 3y plus 3 is the power. 2 raised to 3y plus 3 is equaling 2 raised to 3y plus 1 plus 48. So this 48 is not in the power, it's a separate term. 2 raised to 3y plus 3 is equaling 2 raised to 3y plus 1 plus 48. Okay. How do we tackle this? Let's copy this down. 2 raised to 3y plus 3 is equaling 2 raised to 3y plus 1 plus 48. Fine. Now 48 cannot be written as a power of 2, and even if we could write that, how would it help? There is a plus sign in between. So you won't be able to add the powers. When can powers be added? When the bases are the same and they are joined by multiplication sign. But यहाँ पे ऐसे है नहीं. So you remember there was one technique long back in, I don't know which some number, whether it was 3 or 4, what I don't remember. I told you, remember this experience, reverse splitting. So that will come to our rescue. What we can do, we can write this as 2 raised to 3y into 2 raised to 3, okay, equal to 2 raised to 3y into 2 raised to 1 plus 48. Right, so now कुछ फायदा होगा इसका, otherwise in this form तो we just could not proceed only. So this is 2 raised to 3y into 2 cube. See, bases are same, so we can add the powers. So if you perform this operation, it will be 2 raised to 3y plus 3, and which is the previous step, so we are correct. Same way you can verify for this. Okay, now you take all these terms here, let 48 be there. So this will be 2 raised to 3y into, now we will write 2 raised to 3 as 8, no problem, minus 2 raised to 3y into 2 plus 48. You can't add 48 and 2 because this is these two are together, multiplication first. This is little advanced sum, little thought provoking. Now see, observe, this is one term, this is another term, right, joined by minus. So we can't apply any laws of indices because we can't subtract. If this was division and all, it was a different thing. So now what can we do? Elementary factorization. So see, this is the way the experience of certain sums infuses itself in some other sums. This will be 2 raised to 3y. We can take common. In the bracket we will get 8 minus 2. 2 raised to 3y, in the bracket 8 minus 2. Correct? Is equal to, no, what has happened? I made a mistake here, sorry. This term, when you take it on this side, it will become negative, which we have taken care of. This you will take it on this side, so it will become negative, and then equal to sign, equal to plus 48, that means it is equal to 48. Anyway, this is now one term, this is second term. From this we can take 2 raised to 3y common. You will get 8 minus 2 is equaling 48. So this will be 2 raised to 3y into 6 is equaling 48. This will be 2 raised to 3y, 48 upon 6. This is 8. So 2 raised to 3y is 2 raised to 3. 8 can be written as 2 raised to 3. So what happens? The bases will be equal. So we can now equate the powers. So we will have 3y is equaling 3. So y will equal 3 upon 3, that is 1. So ultimately we have easily solved, and y, this is a little different sum, but it's quite important. Okay. So y is equaling 1, and this completes with your question 7. Question 8, simplify 8x raised to 4. So it is 8 into x raised to 4. The whole raised to 1 by 3 divided by x raised to 1 by 3. Okay, let us see. This is 8x raised to 4 raised to 1 by 3 divided by x raised to 1 by 3. Now see, there are many ways in which you can approach this sum. I will show you 2 ways which come to my mind right now. Observe that the powers are the same. So we can fuse the bases and write a common power. See, recall this law, a upon b, the whole raised to m. That is a raised to m upon b raised to m, isn't it? So conversely, a raised to m upon b raised to m will be a upon b, the whole raised to the common power. So that we can use because the two powers are the same. So first technique I will show you that way. Now this will be written as 8x raised to 4 upon x, the whole raised to 1 by 3. So x raised to 4 and x will get cancelled, right? A simple algebraic simplification. So this will be 8x cube, the whole raised to 1 by 3. Now, yeah, x raised to 4 x raised to 4 upon x is how much? X cube, and then into 8. So that is 8x cube the whole raised to 1 by 3. Now this is of the type, this can be written as, how do we simplify this now? The common mistake made by you is this sum appears simple, but there are many pitfalls, and hence I have chosen this sum. They will say, okay, most of the students will say 3 into 1 by 3, a raised to m the whole raised to n. That is a raised to mn. So 2 powers will get multiplied. 3 into 1 by 3 gone. So answer is 8x. But that won't be correct, because this is 8x cube the whole raised to 1 by 3. You have ignored 8 and you have given the power only to 3 if you think like that. So now how to tackle? So we will have to write this as 8 into x cube raised to 1 by 3. Okay, because this power is meant for 8 also, it is meant for x cube also. Na? There is a multiplication sign. What is that law? Just to refresh your memory, a into b the whole raised to m. This will be a raised to m into b raised to m. M has to be given to both. We can't just ignore one thing. And this situation is exactly like this. So I am writing this as 8 into x cube the whole raised to 1 by 3. Okay. Now this 1 by 3 power needs to be given here. 1 by 3 power needs to be given here. So this will be 8 raised to 1 by 3 into x cube raised to 1 by 3. This will become 2 cube raised to 1 by 3, and power raised to power, a raised to m raised to n, a raised to mn. So this will get cancelled, it will be x. This also will get cancelled, this will be 2 raised to 1, 2 into x, that is 2x. Got it? Or at this stage you should have realized that this is one technique. Or at this stage, so this you are clear, na? I'll show you that. Let me erase this now. Or what we can do, once we come till here, this can be written as 2x the whole cube. 8x cube can be written as 2x the whole cube, because 2x into 2x into 2x will give you 8x cube. And then the full thing raised to 1 by 3. Now it becomes of the type a raised to m the whole raised to n. So that is a raised to mn, the 2 powers get multiplied and you are left with 2x. This is fine. Okay. This was one way of looking at the sum. Let us see if there is any other way in which we can think for. Now here luckily powers were same. 1 by 3, 1 by 3. What if the powers were different? Then we had to simplify this and this separately and then take it. This x and all would be there, but I am talking about the powers. Okay, so let's do one thing now. Instead of taking this sum in a different way, let's make the power only different. Okay, and see. We will now take this as question number 9. Okay. Question number 9, simplify, तो ठीक है. This let's make it 1 upon 5 and see how the sum now behaves. Okay. So now the question says, question 9, new question, simplify 8x raised to 4 the whole raised to 1 by 3 divided by x raised to 1 by 5. Now we cannot fuse the bases because the powers are different. So let us see the approach for this. 8x raised to 4 raised to 1 by 3 divided by x raised to 1 by 5. Now we can't fuse the bases like powers are different. Okay, so we'll come here. Now this can be written as 8 into x raised to 4 raised to 1 by 3. Nothing wrong. Okay. Divided by x raised to 1 by 5. Now this is a into b, the whole raised to m. A into b, the whole raised to m. So that is a raised to m into b raised to m. Okay, so give the powers to both. 8 raised to 1 by 3 into x raised to 4 raised to 1 by 3. The whole divided by x raised to 1 by 5 will remain as it is. Okay, now what to do? This can be, now I'll skip some steps. Okay, this can be written as 2 cube, 8 can be written as 2 cube. So 2 cube raised to 1 by 3, 2 cube raised to 1 by 3. So this will get cancelled. A raised to m, the whole raised to n. What is that? A raised to mn. So this will be 2 raised to 3 into 1 by 3. Okay, na? A raised to m, the whole raised to n is a raised to mn. So it will come 2. So now this expression will reduce to 2 into, again the two powers will get multiplied. This is x raised to 4 by 3, the whole divided by x raised to 1 by 5. So 2 will remain 2. This we can apply some law of indices. X raised to 4 by 3 upon x raised to 1 by 5. The bases are same, joined by division sign. So powers will get subtracted. Now you will say, why not this term be given to 2? No, this is multiplication sign. Na? So the denominator can be given to one of the two. Something if it is like 8 into 7 upon 2. So we can give 2 to 8, or we can give it to 7, not to both, if there is a multiplication sign. If there is a plus sign, if it was 8 plus 7 upon 2, then you can do 8 upon 2 plus 7 upon 2, and that is okay. Even if it is minus, you can do 8 upon 2 minus 7 upon 2. But if it is multiplication sign, then the denominator can be given to one of the two at a time. Coming back to this, this will work out to be 2 into x raised to 4 by 3 minus 1 by 5. Which law? A raised to m upon a raised to n, that is a raised to m minus n. So this will be 2 into x raised to, we can take the LCM 15. 15 upon 3 is what? 5. 5 into 4 is 20. This will be 3. So this will work out to be 2 into x raised to 17 by 15. And this is your answer, like this. So your final answer will be 2 into x raised to 17 by 15. See how the sum took a drastic turn by making a small change. Even our approach changed and it took a very interesting turn. Fine. So understand the difference between question 8 and 9 and keep this experience in mind. So that completes with your question 9. Question 10. Solve for m. This is given 2 cube into 5 raised to 0 plus 3 raised to 2m is equaling 8 upon 27. Okay. Now see, how do we go about this? Certain simplifications need to be done. 2 cube is 8. 5 raised to 0 will be 1. 1 plus 3 raised to 2m. 8 upon 27, mixed fraction. So it will be 27 into 8 plus 8 upon 27. That will come to 2 to 4. 2 to 4 upon 27, right? Converting mixed fraction into an improper fraction. Fine. Our target is what? To find m. So 3 raised to 2m is combined with 1. So we'll have to first get the value of this and then see. So 8 will go down now, right? Because it's 8 into, na? So it will go down. So this is 1 plus 3 raised to 2m, 224 upon 27. This is originally there, upon 8. This will be 1 plus 3 raised to 2m is 224 upon 27. This is the main division line now. This will become into 1 upon 8. So 1 plus 3 raised to 2m. This will get cancelled. Yeah. 8 2s are 16. 6 remainder. 8 8s are. This works out to be 28 upon 27. Now try to isolate this 3 raised to 2m. That is positive only. Good. So no problem. And this 1 we will take on this side. If this was negative, 1 minus 3 raised to 2m, then this term we would have taken on that side to make it positive, and this would have come here. So this is 28 upon 27 minus 1. Okay. So 3 raised to 2m is equaling, and this if you simplify, this will LCM if you take, it will give you 1 upon 27. So it will be 3 raised to 2m. Now we have to try and make the bases equal. This best we can write it as 1 upon 3 the whole cube. What else? We can't write this as 3 cube. 3 cube will be 27. But this is 1 upon 27. So it will be 1 upon 3 the whole cube. Now observe, this is 3 and this is 1 upon 3. So bases are not the same. So we won't be able to equate the powers. But this is 3 and this is 1 upon 3. Is something striking your mind? How will we make this base equal now? Simply take the reciprocal of the base. Simply take the reciprocal. If you take the reciprocal of the base, the power will change the sign. So this you write it as 3 upon 1 raised to minus 3. This is nice, isn't it? What is that law? A raised to minus m is 1 upon a raised to m. So when you reciprocal the base, the power changes the sign. So we have done the same thing here. Okay, so this will be 3 raised to 2m. 3 upon 1 is 3, so no problem. Is equaling 3 raised to minus 3. Bases are same, so powers are same. So 2m is equaling minus 3. M will be minus 3 upon 2. Done. This completes your interesting sum, question number 10. Now see, sometimes inside they will give you numbers like 0.6 and all. So don't get bewildered how to tackle. I'm just telling you, here it has not come, but this is just an input which I would like to give. Suppose you have something like 0.6 raised to something, then you write 0.6 as 6 upon 10, that is 3 upon 5. And then you proceed in a normal way. Suppose if 0.6 comes somewhere and all. Okay, so this completes your question 10, and we have come to the end of the topic of indices. Hope you liked it, and thank you so much.